All right, so this little video is going to go over how to multiply polynomials, okay? And so first thing we talked about, okay, that we need to review is the difference between adding and subtracting terms and how to multiply terms. Okay, so let's review real quick when we add and subtract. So for instance, suppose that we're going to take, let's start really simple, and we're going to take 2x and we're going to add it to 3x. Well, when we add and subtract, okay, we just add the coefficients, but the exponent doesn't change. So if you add a linear term plus another linear term, the outcome is going to be a linear term. If we suppose we have negative 5x to the third power, and we add that to 4x to the third power, see again, we have like terms because they're both, the degree is 3, they're like terms. And so we can then add negative 5 plus 4, and we get negative 1x cubed, but you don't have to write the negative 1, okay? Well, then what happens is we, say we have a situation where we want to take a negative 5x cubed and we want to add that to an x squared. Well, what happens here is this is not like terms. And so we would not condense that expression. We would leave it as a binomial, negative 5x cubed plus x squared, and we couldn't actually combine those two terms together. And so we would just leave it. But multiplication is a little bit different. But when we multiply terms and we take 2x times 3x, we multiply the coefficients and we take 2 times 3 and we get 6, okay? But then we also multiply the x times x, which increases the exponent and makes x squared. So really what you're doing here, the exponent rule that we're doing is if you have x to the first times x to the first, what we're doing is you're adding your exponents 1 plus 1, and that's where the 2 is coming from. So if we have a negative 5x cubed and we times that by a 4x cubed, okay, then what we're doing is, again, we're going to multiply the coefficients, negative 5 times 4, and get negative 20, but then we also multiply the x cubed times the x cubed, and we're getting x to the 6th power because we're adding the exponents. And so just one more thing, really just to help you understand is what this is saying is if x cubed means you have 3 x's. X cubed here means x times x times x. Well, if there's 3 x's in the first quantity and 3 x's in the second quantity, that's what's making it add up to mean 6 x's total. Now, what's interesting with multiplication is you do not need like terms to be able to multiply. And so while we couldn't add negative 5x cubed plus x squared, we can in fact multiply them. We multiply the coefficients. So this is like taking negative 5 times 1, and we take, there's x cubed here times x squared, and that's going to make x to the 3 plus 2 power, which is 5. So again, this is like saying x times x times x is x cubed, and x times x is x squared. And so what we're doing is saying that we have 5 total x's. That's why you add your exponents. All right, so with that little review, let's go ahead and look at our first example. Okay, and we are going to, let's suppose that we have something like 4 times x squared minus 3x plus 1, and we're going to add that to 3x times x squared minus 2x, and we'll go ahead and just say we multiply by that, okay? So we're going to kind of combine, getting into this, what we did with adding, subtracting, and we're going to add in multiplication. So first thing we're going to do is we're going to multiply, and this 4 times the parenthesis means that everything in this quantity needs to be multiplied by 4, okay? So 4 times x squared, 4 times negative 3x, and 4 times 1. Now over here, let's make sure that when we multiply a 3x, that we use that exponent property correctly. 3x times x squared is going to make this 3x cubed, right? Because this is x to the first times x squared. And 3x times negative 2x is going to make negative 6, and x times x makes x squared. So we would increase the exponent. So now I go to combine like terms, and I see that I have an x cubed, and there's nothing to combine it with. So let's bring that down. And then I have my x squared terms, and I notice that there's a 4x squared and a negative 6x squared, which is going to combine to make a negative 2x squared. I see that we have this linear term right here with nothing to combine it with, so let's bring that down. And then finally, I see that there's a plus 4 and there's no other constants. Okay, so that was just a good little kind of warm-up problem for getting into multiplication. What we're going to spend a lot of time doing today is this idea of double distributing. Okay, when we take a binomial times a binomial, you might have heard this before with the acronym FOIL, but I like to think of it as double distributing, because what we're going to do is we're going to take the 3x and we're going to distribute the 3x to both terms. And then we're going to take the 5 and we're going to distribute the 5 to both terms. So that's kind of the game plan right there. Well, 3x times 2x is 6x squared. When I take 3x times -1, it's -3x. Okay? Well, now let's go ahead and distribute the 5. And so this is going to be 5 times 2x, which is 10x, and 5 times -1, which is -5. And so what you're going to often see with these is that the two terms in the middle, okay, are going to be like terms, and we can combine a -3x and a positive 10x to make 7x, okay? And so a lot of times we can combine like terms right here, and this would be the polynomial written in standard form. All right, so the next thing that I want to do is let's talk about, you're going to see this come up a lot, where we're going to see a quantity squared. So suppose we have 3 minus 4x squared, okay? So how are we going to do this? Well, the first thing that we're going to recognize is that when something is squared in math, that means that you times it by itself twice. And so if we were to have quantity x minus 5 squared, that would mean x minus 5 times x minus 5. And so what we're going to start out doing with this problem is we are going to expand it to be 3 minus 4x times 3 minus 4x, okay? And then we're going to go through and we're going to double distribute. Now, if you're feeling comfortable with this, feel free to hit the pause key, work through the problem, and then hit play when you're ready and see if you got it right, okay? Well, let's go ahead and distribute the 3. 3 times 3 is 9. 3 times -4x is -12x. And then I'm going to distribute the -4x. So -4x times 3 is another -12x, and -4x times -4x is going to become a positive 16, and x times x is x squared. Okay, so let's go ahead and combine like terms, and I notice first that I have a 16x squared. This term right here, this -12x and -12x is going to make -24x, right? It's a negative plus a negative. And then finally the constant term is 9, and there's nothing to combine it with. All right, so let's move on to a different kind of example, because I think you are getting the hang of this. Let's suppose that we have something like, let's go something like 2x squared plus 3y squared, and let's times that by 2x squared minus 3y squared, okay? So again, we're going to double distribute, and we're going to take the 2x squared and we're going to multiply that to both terms. So 2x squared times 2x squared is 4x to the 4th power, okay? And 2x squared times -3y squared, let's multiply those coefficients. Now when we take an x squared times a y squared, all we can really do is just condense it and multiply it, make it x squared y squared. So we just kind of smush that term together there. Now let's multiply the 3y squared times the 2x squared. And so what we're going to get is a 6 again, and then we're going to get y squared times x squared. Now I'm going to go ahead and understand that, you know, taking x squared times y squared is the same thing as taking y squared times x squared. So whether we put the x squared first or the y squared first, it doesn't really matter, okay? So then finally, when I take 3y squared times -3y squared, it's going to be -9y to the 4th. So in the middle here, what we see is we have what we call like terms again, because the x squared y squared, the -6x squared y squared, and the +6x squared y squared can combine. So what we've got is we have 4x to the 4th and there's no other like terms. See, this is a fourth power, but it's y to the fourth, so they have to be the same variable. Well, a negative 6 and a positive 6 are going to cancel out, and then I'm left with a negative y to the fourth. And again, since they're not the same variable, these are not considered like terms. Okay, well, the last example that I'm going to do is going to be how we would maybe take something like a minus 2 times a squared plus 3a minus 5. Okay, so let's practice taking a binomial times a trinomial. And like I've said before, if you think you know what to do, why don't you hit the pause key and try it, and then hit play when you're ready. And if you want to follow along, then let's kind of do this together. So here's the game plan. We're going to take that first a and we're going to distribute it to all three terms. So a times a is going to make a cubed. A times 3a is going to make 3a squared, and a times negative 5 is negative 5a. Okay? And then we're going to take the negative 2 and multiply it by all three terms in that second quantity. So we're going to get negative 2 times a squared, negative 2 times 3a is negative 6a, and negative 2 times negative 5 is plus 10. So finally we combine like terms. And I don't see any other a cubed, so I'm going to copy this down. Let's find all our a squared terms. Positive 3a squared and negative 2a squared is going to condense to make a positive a squared. And then I see a negative 5a and a negative 6a, which is going to combine to make a negative 11a. And finally, we have a constant term of plus 10 with nothing to combine it with, so I'm going to bring down the plus 10. Okay? Well, hopefully that's enough to get you started and have you feel confident with your homework, and we can go over any additional problems from there. So thank you for watching. Hope it helps.